Next, we look at question number 2. The question asks you to account for the observation, okay, that the slow rates of hydrolysis of a primary chloroalkane can be markedly increased by a small amount of Ki. Okay, so first of all, right, let's go back to very basic chemistry. Ki is an ionic compound. So please remember that it's an ionic compound. It's not a covalent compound, all right? So Ki, if you put it into water, it will straight away ionize to give you K plus I minus. That's very clear cut. Okay, so we need to understand something really quite interesting here because water on its own, right, it's actually the solvent, so it will not ionize on its own. So we saw some answers that simply have OH minus as the nucleophile. This is not possible. Okay, so take note that it is almost impossible for you to have OH minus. Sorry, the pen is not working very well. So just give me a while. Yeah, so it's not possible for you to have OH minus as the nucleophile. So if you put OH minus as a nucleophile, you're on the wrong track. So remember this, you can't have OH minus because the concentration of OH minus, if you recall from your KSP, it's only in the region of 10 to the power minus 7. Okay, so it's a very low concentration. So at any one point in time, the probability of a nucleophilic attack by water is actually much higher. So in this first equation, right, we are really saying that if we have water alone, the reaction is very, very slow. Okay, so that means that you probably want to be aware that water itself is number one is a poor nucleophile, and then number two, Cl is a poor leaving group. Okay, we probably want to be aware of that. Chloride is a poor leaving group. So the nucleophilic attack by water on the rear of the CCl bond. Okay, so if you want to draw this structure out, CCl here, and then you probably have H, and then you have H, and then you have a long alkyl chain. Okay, so definitely water approaching from the rear is possible. Okay, it's possible, but slow here implies high PA. Okay, so this is the link that you might want to see. Okay, so it's possible, but very high EA, so very slow. But why is it that when we add Ki in, the reaction becomes very fast? So when we add Ki in, what are we introducing into water? We are introducing I minus. Okay, so in the presence of water, I minus being a highly polarizable anion is actually a relatively decent nucleophile. So instead of water here, we are expecting I minus to perform the real attack instead. And you kick out the Cl. So when I minus perform the real attack, we are going to get the nucleophilic, or rather the SN2 product, the nucleophilic substitution product. That looks like this. Yes. Now, when this happens, you might want to notice one interesting phenomenon. Now, iodide is a much better leaving group as compared to chloride. Yeah, so when I replaces Cl, now I'm opening up cans of worms. Now the Ci bond is quite readily broken. So therefore, water being in abundance, it will then perform a rear attack and then you kick out the ion. So the conundrum here is probably iodide is both a good nucleophile and a good leaving group. Something that you might want to think about, why is that the case? Okay, so that will be the end of the debrief for question 2.